A very pleasant day to everyone. We are from Group 10. We have chosen Bernoulli's Law as our project too. I am Angelina and Anthony Sami, ID TG20060, and I would like to introduce my group members. Kartika Naidu Analalaki Tinagaran, TG20055, Izzati Zawani binti Muhammad Rasdi, TG20041, Nurul Iza binti Muhammad Sabri, TG20030, and Haziman Hakim binti Muhammad Zahari, TB21038. Introduction. According to Bernoulli's principle, an increase in a fluid's speed occurs concurrently with a drop in pressure or a decrease in the fluid's potential energy. The statements assert that in a constant flow, the sum of all kinds of energy will be the same at all places along the streamline. Bernoulli's theorem pertaining to a flow streamline is based on three assumptions, which is steady flow, the incompressible fluid, and no losses from the fluid friction. The validity of Bernoulli's equation will be examined in this experiment. The objective of this experiment is to determine the velocity volumetric rate of the fluid existing in the orifice of the water bank and to determine the coefficient of contraction.
Equipment list for this experiment. Number 1 is plastic bottle. Number 2 is baking pan. Number 3 is plastic jug. Number 4 is sellotape and water.
The method for this experiment is, first of all, put a hole on the water bottle and close the hole using a tape. After that, fill the color water into an empty bottle until 15 cm. After we pour the water, place the water bottle in the tray. After that, start the stopwatch after take out the tape from the hole. And stop the stopwatch when the water stop coming up from the hole. After that, repeat the step for 10 cm and 5 cm respectively.
Okay, this is for the setup for the Bernoulli's principle. Okay, so the first experiment, we should fill the color water into this empty bottle, which is height of 15 centimeter. The first thing is when you open the sellotape, please make sure the stopwatch is started. So it took 32 seconds for 15 of height centimeter of water to stop the fluid come out from the empty bottle.
Okay, for result, okay, we have three parts. Is height. Part 1 is height water level from hole in cm. Number 2 is times in second, and number 3 is distance between water and bottle in cm. Okay, number 1, the result is height is 5.0 and the time is 32.63 and the distance between water is 3.3. Number 2, height is 10.0 and the time is 26.3 0.69, the distance is 4.7. And number 3, lastly, height is 15.0, time is 18.80, and the distance is 5.5.
Next is discussion.
This experiment was conducted to investigate the volumetric flow rate of the fluid leaving the orifice of the water tank and also to calculate the jet velocity of the water tube. The experiment also performed to calculate the coefficient of contraction which is available in the system. In this experiment, we found that the flow energy is directly proportional to kinetic energy with time. This is because flow energy basically is work done by pressure forces on a fluid element, and this work must result in the change in kinetic energy of the element. It means that the change in kinetic energy of the fluid element is the result of work done by pressure forces. The coefficient of contraction is defined as the ratio between the area of the jet at the vena contracta and the area of the orifice. The larger the coefficient contraction, the velocity of the fluid flow will be larger too. To manage the impact is by changing the diameter of the vena contracta to eliminate or minimize the recirculations and thus losses. This is because the dissipation of the energy caused by these recirculation regions means that not all the pressure drop is converted to kinetic energy, and irreversible components of pressure drop must be considered.
Okay, the last one is conclusion. The experiments that took place has proved the understanding of the Bernoulli principle taught in the introduction section. In conclusion, this experiment successfully showed that the higher the distance of the water from the hole, the higher the pressure applied. Here it is shown that the velocity that occurs is low. According to the Bernoulli's principle, when the occurring pressure is low, then it indicates that the occurring velocity is high. Thank you.